Time is often described as an illusion because it is a subjective experience that varies from person to person. Our perception of time can be influenced by a variety of factors, such as our age, physical and mental states, and the environment around us. Additionally, the concept of time is a human invention that we use to measure and track the passage of events and activities. It is a useful tool for organizing our lives and activities, but it is not an objective reality that exists independent of our perception. Furthermore, the laws of physics suggest that time may be relative and not absolute, meaning that it can appear to pass differently depending on the observer's frame of reference. For example, time can appear to pass more slowly for objects traveling at high speeds or in strong gravitational fields. Overall, while time is a useful and necessary tool for organizing our lives and understanding the world around us, it is not an objective reality that exists independently of our perception and experience. Time dilation is a phenomenon predicted by Einstein's theory of special relativity, which states that time appears to run slower for objects in motion relative to an observer who is at rest. This means that if two clocks are moving relative to each other, one clock will appear to tick slower than the other. The effect of time dilation becomes more noticeable as the speed of the moving object approaches the speed of light. At very high speeds, time can appear to slow down significantly for the moving object, which can result in time appearing to pass more quickly for the observer who is at rest. In physics, time is often considered the fourth dimension. This is because, in the theory of relativity, time and space are interconnected and are referred to as spacetime. The three dimensions of space, length, width, and height, are combined with the dimension of time to create a four-dimensional spacetime continuum. This means that an event in spacetime is described by its position in three-dimensional space and its position in time. Twin paradox. Suppose one twin stays on Earth while the other travels in a spacecraft at a speed close to the speed of light for a few years. When the traveling twin returns, they will have aged less than the twin who stayed on Earth due to the effects of time dilation. If you leave Earth at age of 15 in a spaceship at speed of light and spends 5 years in space, when you get back on Earth you will be 20 years old. But all of your friends who were 15 when you left, will be 65 years old at that time. It's very unlikely that any of us will occupy the same region of space from one second to the next ever again because our whole galaxy is moving through the universe at around 2.1 million km/h. So when we go home, we think our house is always in the same place, but technically, relative to the rest of the universe, it's not. There is no fixed location anywhere in space. Only the speed of light is the true constant in all reference frames. That's where the theory of relativity comes about. Time, a mystery. Time is a concept that has puzzled humans for centuries. It is a mysterious force that seems to govern our lives and the world around us. Despite our best efforts, we have yet to fully understand its nature and properties. On a basic level, time can be defined as the progression of events from the past, through the present, and into the future. It is often measured in units such as seconds, minutes, hours, and years. However, this definition only scratches the surface of what time truly is. One of the biggest mysteries surrounding time is its relationship to space. According to Einstein's theory of relativity, space and time are interconnected and can be thought of as a single entity called spacetime. This means that time can be affected by gravity and the curvature of spacetime, leading to phenomena such as time dilation and time travel. Another mystery surrounding time is its directionality. We experience time as flowing forward, from the past into the future, but there is no fundamental law of physics that dictates this direction. In fact, some theories suggest that time could be reversible, meaning that events could happen in either direction. Overall, time remains a fascinating and mysterious force that continues to capture the imagination of scientists, philosophers, and everyday people alike. While we may never fully understand its nature, we can continue to explore